For our project, we had to demonstrate equations of motion with a multi-pulley dependent motion system. This is our apparatus, which mass B is 5 pounds and mass A is 10 pounds. As you can see, mass B can easily lift mass A, which is twice its weight. In this video, we're going to show you exactly how this is possible, as well as find acceleration.
In this part of the video, we are going to explain how the pulley system works. The first step of any problem is to draw a diagram and a free body diagram. So in this diagram, I have shown that there is two weights, weight A and weight B, weight A being 10 pounds, weight B being 5 pounds, that there is two ropes, rope 1 and rope 2, and that there are 4 pulleys. And in the free body diagram, I have done a free body diagram of block B, pulley C, and block A and the pulley that it's attached to. The second step is to analyze the diagram. The first part of analyzing the diagram of any pulley system is usually to draw a datum line. And this datum line is drawn here because everything above the datum line is not moving. Positive is down, and from the datum line to the center of where block A attached to the pulley is SA, and from the datum line to the center of pulley C is S sub C, and from the datum line to where the rope attaches to block B is S sub B. And in the free body diagram, there we are going to analyze the forces. So there is a weight B being that is going downward, and there is a tension of rope 1 being pulled upward. In pulley C, there is it is still part of rope 1, so the tension remains the same as it was in block B. So there's a tension being pulled up here and a tension being pulled up here. Therefore, there is twice the tension being pulled on rope 2. So in the analysis of block A and its pulley, it's rope 2 going around the pulley, so twice the tension of rope 1 being pulled up here and twice the tension of rope 1 being pulled up here, and being pulled down is the weight of block A. The next step is to determine A sub B in terms of the acceleration of A. This problem takes two parts because there are two ropes. So first, looking at the light brown rope, which we call rope 1, the length of the rope is equal to SC, which is right here, plus SC right there, and then plus SB, which is right here. And that simplifies down to 2SC plus SB. And then you take the derivative of that, and L1 derives to 0 because it's a constant length. It's not going to change. And the rest of it, right here, derives down to 2 V sub C plus V sub B. Take the derivative of it again, and you get 0 equals 2 A sub C plus A sub B. And this can be written as A sub C equals negative A sub B divided by 2. This equation is important and will be substituted later down here as shown. So I'm going to call it equation star. So looking at the second rope, the darker one, the length of it is equal to SA right here, plus this length right here, which is SA minus S sub C. And that simplifies down to 2 S sub A minus S sub C. Take the derivative of it, and you get 0 equals 2 V sub A minus V sub C. And then take the derivative of it once more, and you get 0 equals 2 A sub A minus A sub C. And we will substitute in negative AB divided by 2 for A sub C because of this equation star. So I've written right here, substitute with equation star. 0 equals 2 A sub A minus, this is a substitution, negative A sub B divided by 2. and this can also be written as a sub b equals -4 a sub a. Step 4 is to determine the tension of rope 1, acceleration of block A, and acceleration of block B. This equation on the top here is what we determined in step 3. Acceleration of block B equals -4 acceleration of block A. The next step is to look at the block A's free body diagram and do an analysis using Newton's second law. Summation of forces equals mass times acceleration. So the summation of forces is 2t plus 2t is 4t minus the weight of block A, giving us a summation of forces is equal to the mass of A times the acceleration of A. And block B will do the same analysis with tension going up minus the weight of block B going down is equal to the mass of block B times acceleration of block B. The mass and acceleration of blocks A and B is determined by taking their weights and dividing it by 32.2 feet per second. So now we only have 3 variables left. We have tension of rope 1, we have the acceleration of block A and the acceleration of block B. And we also have 3 equations, so we can solve for each of our 3 variables. The tension of rope 1 is equal to 4.17 pounds. The acceleration of block A is 5.37 feet per second squared, moving upward, and acceleration of block B is 21.47 feet per second squared, moving downward.
We used the clip of the multi-pulley system to calculate the time it took for each weight to travel the measured distance. Then, we used one of the constant acceleration formulas to determine the measured value for acceleration for each weight. As you can see, acceleration for A equals 4.83 feet per second squared, and acceleration for B equals -17.65 feet per second squared. Therefore, the acceleration of B equals -3.65 the acceleration of A. We were not able to measure the heights as precisely as desired, therefore our measured relationship between A and B is different than the theoretical relationship. I hope this video helped you learn about equations of motion with a multi-dependent motion system. Thanks for watching.